This last one? Oh, this one ah? This one. Oh, Xiao Yan ah?
Playboy. Player, not playboy. Player one.
Yes, Ying Hong, do you get the answer? Different from a friend, what?
1.79.
1.7, correct, 1.79 is correct. Or 1.7857. Ah, different? Why looks like some of you do not get it? Anyone do not get it, raise your hand. So I can cross-check your answer. I think some of you look like very relaxing sitting there already, so yes. 1.79 or 1.7857. Can I? Okay, the rest I think maybe revision time I will go through with you again. So let's try and do as much as past year we can from here. I think we've discussed this before. Discussed this before. Okay, we actually almost finished all the past year questions that we have. You all can look at. You don't have to do this question 4, but you look at this question 4. It's something that is from your tutorial. Right? Anyone want to discuss this again? Because this is actually extract from your tutorial, but we just change the term here and there. Should be fine. Then we can spend time on doing other question. Okay? What? That question is pretty much like the same one like you have in the tutorial. The one that I showed you just now. So let me find something that is that can make you think one. Okay, nice. I think question A we did before. Question B we did before. Question C also we did already. Question D. Okay, question D. Calculate the suitable damping ratio. Okay, for a pressure transducer to be used, blah blah blah, provided the frequency is this, and then the dynamic error of the amplitude is required to be less than 2%. I will share with you the working, but I want you to try and do first, okay? So dynamic error equals to negative 2%. So what does this mean? So you have to do something about it, right? Try and do first before I share you the solution. So this one actually means M equals to, I just need this term from you. M equals to what? If let's say dynamic error is required to be less than 2%, so your magnitude ratio will be 0. Think about it. Think about it. If you can figure out this magnitude ratio based on the dynamic error, then you are actually already at least 70% there already.
现在也咸菜了，点到这样，这样子拿。
Zhongzhe, what have you figured out for the value of this magnitude ratio based on the question? Yes. You all did already, why you want to do again? Jongja, you weren't there when we discussed this? Ah, exposed already. A, B, C, E we do already, I think A, B, C, E. We do A, B, C, E in the class already. Why Shavian find it like never see this because it never come? Yes, Jongja, have you figured out what's the M for this question? Because once you figure out this, I think the rest is just... Yes, Wilbur? You just need to find what is the M for this. Because you are looking for suitable damping ratio, right? So you have this, you know what is the frequency already, and you also know what is the natural frequency. And the dynamic error is given. So how to find the damping ratio? If you refer to lecture 6, this one is actually calculated. Let me find magnitude. Right, so you have everything there except you were asked to find the damping ratio if I want you to have a dynamic error that is less than 2%. So in this case, M will be
0.02.
0.02 at 0.02. Your dynamic ratio is negative 2%. So look at the question now. So your dynamic error is negative 2%. So your dynamic error is actually M minus 1, isn't it?
0.98.
0.98, correct. Yes, 0.98. Okay, once you have figured out M equals to 0.98, what can you do from here? So you know that your magnitude ratio formula is 1/1 minus blah blah blah, so equals to 0.98. So from here, you have the value for omega, you have the value for omega n, You have everything except the damping ratio, which is what we were supposed to find. So the rest is just finding this damping ratio after you have figured out what is the value for magnitude ratio based on the dynamic error. Because your dynamic error is required to be less than 2%. So this one will be, if let's say your dynamic error is negative 0.02, right, equals to n minus 1. Okay, right from here. Right, the dynamic error of the amplitude is required to be less than 2%. Right, the rest is I think it's based on your skill of using your calculator already. Right, you sub this, by using this whole entire amplitude ratio equals to 0.98. So how do you find the damping ratio from here? Omega is given, right? Omega n is also given, so you have to do something with it. Actually, you don't really need to convert this to omega, right? Because you know that from your formula, your omega over omega n is in ratio. So 2 pi f divided by 2 pi f, actually, at the end of the day, you will get the same thing. So this ratio will be, Wilbur, tell me what is this ratio to make sure you are following. Based on the logic, this is the frequency, right? 300, another one is 900. So what is the ratio for omega over omega n? 1/3, correct. Do you need calculator for this? 300 over 900. So this is 1/3, right? So 1/1 minus 1/3 square, and then the whole bracket you have a square, and then, okay, so I think it's just tedious now. I leave it to you.
这么题目是first order 然后没来看有名的谁之前做的
You will share the answer. So what do you get?
我们用 first order 来找 dynamic error
0.225?
用 first order equation 来决定它的那个
No.
NW
Try again, John. Try again.
Means the MW value is the constant. So in first order and second order only the equation don't change, not change.
Sorry, your MW value is a constant.
Because the MW we get from first order.
You mean the amplitude ratio?
This one. The final value.
Should be 0.98. Right?
Because this one is under first order system, we get the value.
We are working on second order, right? But I think it's still the same. Your dynamic error is always equals to n minus 1, isn't it?
Oh, it's always in first and second also using the same formula. So there's
Correct, 0.7522. Those that get 0.75 also can, 0.7522 also can, okay? So depends on how many decimal you take. So those that get 0.2 something, maybe you have to work on it and see which part gone wrong. I think it's just how you process it.
Damping ratio 哦，那个 second 哦，0.75了。就有1气。哦，因为你 round off 吧，没有啦 ，round off 算过，要2的，一定要2的。放弃5是错了，他们写3个人怎么办？帮我们3到位。
Okay, anyone do not get 0.75? 0.56啊？
好了，cannot accept。
Cannot 啊
？Cannot。3 decimal 吗？
How come you get 0.56 though?
You round off too much.
How about the back row? Kitchen row. 0.5? 7516啊
166不是咩
？7552啦。
167不是咩？
Can 啊 can. 7.56 will really be a little too far. Never mind, I give you some time to figure that out and I will search for a new question for you. But all these questions are a little too simple already, so let me see what else I can test you.
另外一个不是那个管一个圈，那个叫什么？那个我们回去我那个circle的那个什么？像我这个我做。
It's another wow.
没有啦，这个来的。
It's pretty much the same thing. Pretty much the same thing. Hey, can you finish this one? Then we can move on to a last question for today. Not yet, not yet.
我跟你讲哦，闪电这样哦。花了，他选完了，就跟我们闪电哟。来，闪电。
Second order process is so calculate the pressure. Okay, I don't think we have sufficient time for this. Seeing that you're all working quite slow, so I will leave this question 4A for our first question in our noon session, and then I will, after this question, we will just do revision already from there. Okay? More like short recap of lecture 1 to lecture 6, like what you should focus on and things like that. So later we will do this question 4A. Okay, so you want to take photo already? You want to think about it during your lunch hour? Okay, I don't think we have sufficient time because they are waiting to come in 5 minutes. We can't do much here, so we will continue this later in the noon. Okay? Okay, see you later. Start at 1:30, right? See you in the noon. We will continue with this question and then we will do a recap from lecture 1 to 6 already.
可以吗？一个骗人家。
他都可以，我们给他这个50%
哈哈，2000变1000。
没有1000多，工资都最后了。
哪有？我2个多，
因为 cap 5块。